Okay, and you remember, you still recall the Perky plant data. Here you also see clearly the 2 times line frequency of 100 Hertz because China is 50 Hertz. But you have all kinds of frequencies, and these are not harmonics. You look for harmonics of 100, 200, there are none, and 300, there are none. But very clearly, the whole generator housing may be moving. You can see 50 Hertz, it might have come from the rotor, and then 30, okay? So some weird frequency in between. And the 2 horns around the 100. This is the strangest pattern I've seen. So this requires a lot of study with the plant engineer. So showing the water flood of this period, you see the effect of the loading. So the vibration amplitude has been affected like this. Now you are talking about 2-3 days. Okay, the loading change is so rapid, and it's affected the vibration pattern. Remember, the Perky plant was showing a flat top all the way, and hence it's used as a base load. But this rapid change in loading pattern is worrisome, okay? Because the temperature is also going to follow this pattern. And I got data to show. Okay, this data was actually obtained from the scatter output of the plant from China. Okay, so the user interface is different, and on the vertical axis is the actual loading, 600 megawatts, and then going down all the way to 360. Okay, occasionally it go down to 300. Now, if you look at the time scale, okay, and this is within a short time, and yet the loading is swinging wildly. So days 13, 16, and then 19. Okay, so these swings, and then in between there are also intermediate swings. We do not understand why they want to switch the load like this. But one thing for sure, that the temperature recorded at our sensor follows that. You can see there is a trough here, and there is a trough here. Every pattern become a scale, so you can see that. Okay, so our temperature sensor is working very well. Now, although most of the temperature are in good shape, so they are within 50, 54 degree, okay, and the vibration showing the loading pattern and the temperature, it doesn't quite correlate, okay, but there is a switching going on. The temperature goes through several degree difference, and this again we are kind of at a loss also to explain. Okay, here is the scatter output from the plant, and then here you can see again rapid switching of the load, and jumping from 600 to 450, and then sometimes all the way down to 300. Now, amazingly, the water temperature outlet shown by the SCADA system is a constant, more or less constant 60 degree. Unfortunately, it doesn't quite correlate with what we measure. Okay, so what we thought is that the temperature of the water at the outlet is an aggregate temperature of all the end winding, and they have no possibility to differentiate them. But luckily, they have our sensors attached at various places, and we can show them that some channel is dangerously close to 100 degrees C. Okay, so they're all different. For example, channel 10 shows a fairly normal temperature, and channel 9 was the one that goes up to 100 degrees C over a 1 month period. Now, that will slowly eat away the life of the generator. And then channel 11 shows up and down. They are all different. So how do you explain that when the SCADA system show you a more or less constant temperature of 60 degrees? So here, channel 10 is up and down, but it's okay with 55 to 65. So you can see that. And channel 9 goes up and up to 100. I think it is a problem. What happened is that prior to this, they might have already gone into this situation many times without knowing it. And so the end winding at channel 9 will be a suspect. And we will be working very closely with the plant about this. And yet, channel 11 was showing this temperature up and down, going 60 to 90, and then goes back down. Now, I do not know at this moment whether this is loading related, but this is, you remember that we were showing loading rapid changes? This data is collected over many days. Okay, so there is something independent of the loading. So we need to investigate that. The way the China reference operate was using very rapid change in load. This is very unusual because coal-fired power plants are usually used as a base load. You can see from the data they are switching constantly. This and being followed by the temperature pattern will introduce momentary expansion and contraction, and this will not be very good for looseness. And so the machine unfortunately may be abused, and now we might be asking for trouble operating this way. Concerning the burn mark at the connecting ring, we look at the data. Okay, channel 3, okay, that is one of the pair of sensors we put at that spot. The temperature is okay. And then you recall when we look at the vibration amplitude that the two, channel 3 and channel 4, are not the highest. They are actually slightly below. Okay, so they are also functioning normally. Okay, so channel 4, channel 3 temperature is okay, vibration is okay. So to sum up, what we have done is validated to you the ability of TG guard and vibro fiber to measure both vibration and temperature, and then we can take the data and analyze and help you diagnose the looseness pattern developing on the particular side of the generator, the exciter or the turbine end, top or bottom. So it will help to save a little bit time because you will be monitoring it continuously all the time. You now have your finger on the pulse and you know what to do. And by working together with the customer, we can now give them some feedback on how the way they operate might affect the expected life of the generator. In general, we feel that plant engineers or the owners are not sensitized to the temperature. You see, the generator itself has RTD already installed at the stator core. But the stator core, first of all, by the time you get to very high temperature, the generator could have been completely destroyed. Two, the end winding are so far away, they reflect nothing. The core reading has no relation with the end winding, as you can see by having our sensors installed there, and yet we can detect the occasional sensor showing a dangerously high temperature of 100 degrees C. Okay, so we need to work closer with the reference plant in China, and we try to persuade them to somehow to avoid this rapid loading change. So channel 4, channel 3, they continue to be okay, and this is a proof they feel now more relaxed. Okay, and so basically we have finished discussing the data we have collected from 2 reference plants. And do you have some questions you would like to raise and then to discuss it? Because we do not claim to have a lot of experience in this. We like to work with everybody, and then in particular with the plant. This webinar has been recorded, and what we will do is do as the same as SEW-1 and 2. We will be placing them on the web, and in general we have created a top item called SEW. Click on it to select whatever webinar you want to attend. And then in the meantime, this SEW-3 will be given again next week, slightly earlier time to facilitate Europe and Middle East. And then we also have another session on Thursday, next Thursday, for the Far East people. My coordinates are all indicated here. Please give me a call or Skype me if you want, or send me an email concerning any question or discussion point that you would like to have. And I know this webinar is relatively short period, and people might want to look at it again and then start some conversation with us, and you are more than welcome to do that. So once again, I thank everybody for coming and attending the SEW-3. And all of you have a nice day. Thank you.